we are asked to determine if these are inverses of each other. So are these inverse of each other? So when you multiply them, an inverse in math means that when you do the operation, whatever operation you're under, in this case, we're looking at a multiply idea. An inverse would be that when you multiply them, you get the identity. So depending on what your field is or what type of number set you're looking at, that's going to kind of determine what those answers are. So an inverse in normal multiplication is, it gives you the identity. The identity in multiplication normally is the answer of 1. So when numbers multiplied by each other, they equal 1 for normal multiplication. So like 5 times 1/5, 5 and 1/5 are inverses of each other because when you multiply them, you get 1. In this case, the question is, when you multiply A times B, do we get the identity matrix? The identity matrix. The identity matrix in this case for a 2 by 2 is 1 on the diagonals and zeros on the other. All right, so is this going to be our answer? Well, only one way to find out is to multiply them. Well, there's a few ways to find out, but let's go ahead and multiply them. That's kind of the introductory way right here. So we want to multiply them A times B. A times B. All right, well, A is, remember order matters here, 4, 2, 7, -3. Well, and I'm not so sure if order matters when we have the inverses. I would think they would be inverses of each other either way, but let's go ahead and just go through this. 3 over 26 and 7 over 26, -1 over 13, and 4 over 13. All right, so we're going to go ahead and just multiply them out. I'll do a nice big matrix over here. Bam! All right, let's see how we did. So 4 times 3 over 26 is... I'm going to just, let's see if I want to write it out. I'm just going to go ahead and do the multiplication in my head. So when you're multiplying a number times a fraction, it multiplies to the top of the fraction. So 4 times 3 over 26 is 12 over 26 plus 7 times -1 over 13. So that's a -7 over 13. Let me just confirm. 12 over 26, check. 7 over -13, correct. I just want to check. If this is not equal to 1, then, because remember, our identity is 1, 0, 0, 1. So if we're just confirming if they're inverses or not, this has to equal 1. So let's just go ahead and simplify, and then if it does equal 1, we can continue on. All right, so I need a common denominator. Multiply top and bottom by 2. So this turns into -14 over 26. And 12 minus 14 over 26, all of this equals 2 over 26, which is equal to, it's a -2. So -2 over 20, -1 over 13. It's not saying is there a scale factor or anything, because there might be a scale factor that floats around that we can pull out. But I got -1 over 13 for row 1, column 1. So right away, that tells me that these are not inverses of each other. It has to be a 1 right here. So that wasn't too bad. Let's see if the other one's any different, any nicer. No, it's pretty drawn out. So that's the process, is you just have to go through and multiply them all out to see if you get the 1. So your goal is, does A, B, when you multiply them, equal, in this case, 1, 0, 0, 1. And you have to multiply it out to see. There are some other tricks, but we'll get to those later.